Two patients were randomly divided into an experimental group and a control group. So this is a total, but they are giving us the information. N1 is 61, N2 is 41. X1 bar is 11.2, and X2 bar is 3.4. And S1 is 6.4, and S2 is 6.6. Okay. Shows the result that involvement at the experimental group was group 1 and control. So experiment and control. Okay. Test whether the experimental group experienced the larger mean improvement than the control group at alpha 0.05. So, can anyone help? How do we write this? So mu1 equals mu2.
Is it greater than?
Excellent. One tail test, upper tail test. Do we determine T or Z?
T.
Very good. So let's determine T statistic and then the p-value. Done. Great job. So T for 2 samples. So 2 sample T test. Not proportions, but means, right? So that's why we have to choose 4. And we have X1 bar 11.2. And we have S1 6.4. And N1, which is 61. So again, yes, that's correct. And now X2, X bar 2, the mean for the sample 2. And then the standard deviation 6.6. It was 6.6, yes. My dot kind of disappeared there, the period. So 6.6. And the sample size 41. And we have to choose the upper tail test. And I prefer to draw to see the shaded p-value. In the upper tail test. Ooh, nothing! Wow! So 5.9359235, and p-value is 0. Okay, what do we conclude?
Well,
ready.
It's less than the significance level.
Good.
So you reject it.
Very good.
The hypothesis.
Yes. There is sufficient evidence to conclude this. At alpha 0.05. Great job. Okay, now they're also asking us to construct a 95% confidence interval for the same thing. I already have all the information. I think it may transfer. I hope it may transfer to the confidence interval. Okay. We want a T interval for two sample T interval. 2 sample T interval. And it has everything. Thank you very much. And calculate. So we got 5.1815, comma 10.419. Okay. So does our conclusion, or is our conclusion reflected in the confidence interval? Yes or no? In other words, do they meet? Do they match? The conclusion from here and what we see here, do they match? Does the interval contain 0? No. So what does it mean? Are they equal?
Yes.
Are they equal?
No.
No. So this interval is consistently positive. Which of these two could be bigger? If the interval is consistently positive, the difference is consistently positive, which of these two is bigger, mu1 or mu2?
mu1.
Of course. What if the interval, don't change anything, I will erase it. What if the interval is this? Of course, reversed, because negative 10 now is smaller. What if I get negative 10.4, comma, negative 5.1? Which of these two is bigger?
mu2.
Mu2. Mu2. What if I have 0? Or what if the interval has 0? Do we reject or fail to reject? Fail to reject. Very good. So this was 32. Okay, so let's also look at 33. Any questions for me? Okay, so let's look at 33. See what they want in 33. Two researchers conducted a study in which two groups of students were asked to answer 42 trivia questions from a board game. The students in group 1 were asked to spend 5 minutes thinking about what it would mean to be a professor, while the students in group 2 were asked to think about soccer hooligans. I'm sure I remember perfectly this problem. We worked on it in class. These pre-test thoughts are a form of priming. The 200 students in group 1 had a mean score of 25.2 with a standard deviation of 4.5. While the 200 students in group 2 had a mean score of 19.3 with a standard deviation of 3.2. Complete blah, blah, blah. First, they want 95% confidence interval. And then from the confidence interval, I also would like to test. So does not contain 0. So in other words, the question thoughts, I just want to verify what they want. So the researchers are the difference. What does it mean? So let's look at the 95% confidence interval. We draw a conclusion in a minute. So it doesn't say higher or lower. So I'm assuming that what they want is different. The results are different. Well, we'll see in a minute. So let's look at first of all, the 95% confidence interval. Same thing. We're going to use the same. Let's see if it allows me to. No, it does not go back there. Okay. 2 sample t interval. And now we have x1 25.2. Then S1 4.5. And then 200. And then x bar 2 19.3. and S 3.2, and 200 again, and they still want 95. So let's calculate. So 5.1321, comma 6.6679. So they give options, but I don't like these options. I just want us to think. So what does this mean? Since they are not, they don't have an idea about which direction, it's obviously that they are just thinking that those must differ. So we had the same situation 5 minutes ago or 3 minutes ago. So what do we conclude here? What do you think? If we were to conduct this test, would we have rejected or failed to reject the null hypothesis?
Reject.
So because it's correct, because it's consistently positive, it means that they cannot be equal. If the interval contains 0, which it doesn't, then we fail to reject. Because we don't know. Sometimes it's positive, sometimes it's negative, we don't know. But this is consistently positive. So obviously, mu2 is smaller than mu1, according to this sample. So mu1 smaller, I meant to write the other way around. So mu1 is bigger than mu2. So mu2 is smaller because the difference is a positive number. So this must be bigger than this. So mu1 minus mu2 is positive because this is bigger. So mu2 is smaller than mu1, or better, mu1 greater than mu2. So we will reject the null hypothesis because this is consistently positive. It does not have 0. So reject the null hypothesis. So they cannot be equal. And it appears that mu1 from this sample, mu1 is bigger than mu2. That's pretty much all I wanted to go through. We can also look at 34 an ensemble of conduct an interval, then 90% interval for the mean difference, exactly the same thing, mu1 minus mu2. Now, based on what we looked at, any questions for me? Or anything that you would like to go back to or ask about? Any type of problem? Anything? Is there a particular topic that you would like to go back to?
I'm going to go look right now.
Yes, please. Very good. Awesome. Emily, that step-by-step procedure